First off, sorry about the audio. We had no idea that if we plugged into HDMI audio, it wouldn't work. So we tried hard to resolve that and were unable to. All right, my talk's called Lights Out Guerrilla Radio. I'm going to tell you how to hack houses, radios, cars using radio frequencies. So first off, what is software-defined radio? Software-defined radio is a radio for every frequency. So right here I have a software-defined radio, and it will listen and broadcast from 30 megahertz to 6 gigahertz, which is a very, very wide range, and actually it will broadcast outside of that range as well. So why is software-defined radio important? Radio security especially is important because it's kind of everywhere. It's on car key fobs, it's on baby monitors, it's on home surveillance systems, it's on cell phones, it's on SCADA systems, which is in that bottom there. It controls windmills. And there's a guy that comes to TriKC who wrote software to control windmills wirelessly. And it's on drones. There was an incident where the United States had unencrypted drones that they knew about for a long period of time. And they figured nobody's going to break into this. It's a radio signal. It's at 450 megahertz or whatever. Nobody's going to figure out that we're broadcasting our surveillance video over this signal. And what happened was people were buying $26 of hardware like this and listening in on our multi-million-dollar drones, and we still haven't even encrypted all of our drones to this day, and this was in 2008. So, this was the Shiite Muslims, I guess, the rebels that were listening in on these signals, seeing what we were doing over in Iraq. So the point of this talk is so we can build better security, identify the issues, and resolve them more early on before we deploy them. So if you're looking at a radio broadcast frequency like a home surveillance system, one option for an attacker is to jam that system. So if you have a HackRF like I have here, and let's say that's at 2.4 gigahertz, you can actually broadcast a stronger signal and override that frequency so nobody sees anything. Another option is to replay that signal. So if you record a kind of a blank signal or something where nothing is happening on the security system, you can actually just record that info and then broadcast it back. So if your signal is strong enough, then it'll appear that nothing is happening over that surveillance system. Beyond that, you can listen and receive. So basically, if you're sitting there with HackRF or any sort of software-defined radio, HackRF is just one of them, but HackRF is the one I own, so that's why I'm mentioning this talk. You can listen and receive the signal, and then from there you can just decode the information and try to identify what's going on. Beyond that, once you've listened and received, you can actually just transmit a signal. So you can broadcast your own signal, telling the receiver whatever you want. So we'll go into some demos here. At first, I kind of looked around my house, and there's just radio frequencies everywhere. There's radio-controlled devices everywhere. And one of the things that I found was I have a couple of fans that are controlled by remote, that you can set the fan speed and turn the light on and off. So I was like, okay, that's a good target. It's definitely something that's kind of connected to my house and kind of important because you can see if it's turned on and off. Oops, sorry. We'll go ahead and play that demo. So here I am standing outside my house, running a script, and my lights turn on. And then I run the script again, and my lights turn off. And that is pretty cool. It's pretty scary. And I can do it to my house, but there's only so many. You can open up the back of this and choose between like 8 frequencies. So you can affect a wide range of lights with enough power. It's I mean, I can definitely do it and automate my own house, which is cool, but it's also nice, or it's also, I guess, scary to know that if it's a powerful signal, it can affect a whole city or something like that. This isn't going to work, but you can also broadcast your own radio station. I recorded a signal with this mic, and
You are now tuned in to TriKC Radio.
so that's me tuned into a signal that was static before I broadcast to it. I recorded it with this mic at like 640 megahertz and broadcast it back at 91.3. Really not hard, but it's pretty cool to just replay things at different frequencies and see what you can do. So from there, there's other attack scenarios. That's kind of nifty tricks. It's fun to do, but there's other attack scenarios like in an office environment. So I was kind of looking around, thinking about what's actually something that we care about for security, and I have a wireless keyboard here, so I decided to look at that. And here's a picture of the wireless keyboard that I have. Everybody else has the same one. So what I did was I looked at the FCC ID and found out that it was at 27 megahertz, and then I listened at 27 megahertz and was able to find the exact frequency that it was broadcasting at. So here's a video of me listening at 27 megahertz, and you can see, I'll play it here, you can see my keystrokes and my mouse movement. My keystrokes on the right and my mouse movements on the left, and I was able to find the exact frequency that my keyboard was broadcasting at. So from there, I was able to do replay attacks on my keyboard. We'll go ahead and get to a demo of that, and actually I can hop out of this mode here. All right, so here I'm SSH'd into this Linux box, which is controlling the HackRF, and I'm going to run a few demos. Let's do add user first. So I'm telling this HackRF to run the script that I wrote here, and I'll go ahead and execute it. So this is bypassing UAC and adding a user, and these computers are completely disconnected, and now it's adding it to the local admin group. All right, that was replay. So this was playing to this receiver, which I probably could have put closer, but it worked. And so yeah, that was just replaying right now from this HackRF to this wireless keyboard receiver, which is plugged into USB here. So it was telling that what keys were pressed and replaying it and the users added. Sorry, I'm trying to find where users are at. It doesn't usually take. And we can see that it actually added the user here. There's an active user that I just added. We'll go ahead and delete that since you're on the same network I am and you know the password. Beyond that, I can also, another attack that I recorded was a netcat attack. So instead of adding a user, I'll actually try to execute a netcat listener to open a shell. So starting netcat listener on port 31337, and we're listening. So if I connected to this, I didn't want to look up the IP address. I didn't have enough time to prepare, but this is ready to go. I can just have a remote shell. Yeah, I think I will be short on time if I actually look up my IP address right now, though. So I'll go ahead and move on beyond that. All right, so those are two keyboard replay attacks, and those were really cool. I enjoyed them. But beyond that, there's additional attacks. So I wanted to know which keys were being pressed. I can record something that I press, but I actually wanted to know if somebody else owns the keyboard, like in an office environment, which keys are being pressed. So I went to decode the signal, and I started off with something like this. It's just kind of some gibberish up there. It's just some radio noise, basically, and was able to identify the type of modulation that it was using. So once I demodulated the signal, I had a better signal to work with. And from there, it was just a noisy signal. So I applied some additional filtering and was able to end up with a clean signal. That's actually Miller encoded signal. Each of those peaks mean something different, and that's kind of what I ended up with there. And this is the GNURadio graph that I built to get to that point. So once I had built that, that compiles into Python, and I was able to modify that Python to actually decode that into ones and zeros, into bits, and tell which keys were pressed. So we'll go ahead and do a demo of that. So again, I'll connect to I'm on this computer now, just since I can't play two screens at once, and run this key strip. Big shell. All right, so we are listening. This keyboard's completely disconnected. It's talking to that computer, but I'll go ahead and I have it on this table here. And if I type, I should open up something so you can see what I'm typing. All right, so on this wireless keyboard, if I type, this computer can tell what's being typed by this wireless keyboard, and these are, I know they're close together, but they're completely disconnected, so both computers know what's being said. Thanks. Gotta find where my mouse is. On a massive monitor. All right. Okay, so that was it for the demos. So I've shown you how to hack lights, hack computers, and hack cars, and hack FM radio, and also hopefully shown you some reasons to be aware of radio security, and hopefully this gives you some things to think about around your house and helps you kind of think about securing your own devices. Thank you.